Food cans are coated with tin and not with zinc because zinc is more reactive than tin. You are given a hammer, a battery, a bulb, wires and a switch. How would you use them to distinguish between samples of metals and non-metals? Hammer. Metals, when they are hammered, they form sheets, and this property of metals is known as malleability. Whereas non-metals, they cannot be beaten into sheets. Second, a battery, bulb, wire and switch can be used to make a circuit. When metals are connected across this circuit, the bulb glows. Means metals are good conductors of electricity. Whereas non-metals are bad conductors of electricity. If a non-metal is connected in the circuit, bulb does not glow. So non-metals are bad conductors of electricity. Assess the usefulness of these tests in distinguishing between metals and non-metals. So metals can be beaten into sheets, that is they are malleable. Non-metals cannot be beaten into sheets. Metals are good conductors of electricity, non-metals are bad conductors of electricity. Or non-metals are not good conductors of electricity. What are amphoteric oxides? Give two examples of amphoteric oxide. Two examples of amphoteric oxides are aluminium oxide and zinc oxide. Amphoteric oxides are the oxides which react both with base and acid. For example, aluminium oxide reacts with acid to form aluminium chloride and water. Now the balanced equation will be, this will be 2 to balance the number of aluminium, and this will be 3 to balance the number of oxygen, then to balance the number of hydrogen and chlorine. Now to balance the number of hydrogen and chlorine, this will be 6 HCl. As can be seen, aluminium oxide is reacting with acid to form salt and water. What is the physical state of these reactants and products? Aluminium oxide is solid. HCl, aqueous solution of HCl is taken. AlCl3, aqueous solution of AlCl3 is obtained, and water is in liquid state. Now reaction of oxide of aluminium with base. Al2O3 also reacts with base to give salt, that is NaAlO2, which is called sodium aluminate, plus water. Now to balance this reaction, this will be 2 to balance the number of aluminium atoms, and again here 2 to balance the number of sodium atoms. So this is the balanced equation. The physical state of the reactants and product is aluminium oxide solid, NaOH, aqueous solution of NaOH is used, sodium aluminate, aqueous solution is obtained, and water is in liquid state. So as can be seen, oxide of aluminium or aluminium oxide is reacting with acid as well as with base. So such oxides are known as amphoteric oxides. Another example of such oxide is zinc oxide. Now reaction of zinc oxide with acid, it reacts with acid to give salt and water, and zinc oxide also reacts with base like NaOH to give salt, which is known as sodium zincate, having the formula Na2ZnO2 plus water. Name two metals which will displace hydrogen from dilute acids and two metals which will not. Two metals which displace hydrogen from dilute acid: calcium, zinc. These are the metals which displace hydrogen from dilute acids. And two metals which will not: copper and silver. Usually metals lying above hydrogen in the reactivity series, M denotes metal, will displace hydrogen from acids. Whereas metals lying below hydrogen, M dash also denotes metals which lie below hydrogen in the reactivity series. So metals lying below hydrogen in the reactivity series will not displace hydrogen from dilute acids. So reaction of zinc with dilute acid will be zinc reacts with hydrochloric acid to form zinc chloride plus hydrogen gas is evolved, and calcium similarly reacts with HCl to give calcium chloride and hydrogen gas is evolved.